Good afternoon, everyone, once again, and thank you for joining. My name is Davina Gowden, and I'm one of the communications advisors here at RPRA, and I will also be the moderator for today's session. Welcome to RPRA's webinar on the development of recycling efficiency rate, or RER, calculation and verification procedure for hazardous and special products, or HSP. Before we begin, I just wanted to go over some housekeeping. So today's webinar will provide an overview of the HSP procedure and will also be answering your questions. Please note that we'll be stopping at specific places in this webinar to answer your questions, but you may submit them at any time. As you can see on your screen, to ask a question, you can click on the Q&A tab, type in your question or comment, and click send. There's also an upvote or a like feature where you can like another person's question, and what that does is it moves it higher up in the queue and prompts us to answer it sooner. If we can't get to your question today, or if it's very specific to your situation, please email us at consultations@rpra.ca. This webinar is being recorded and will be posted to our website along with the presentation later this week. We'll also be emailing attendees from all sessions to let them know that the materials are ready. So if you want to review anything or revisit them, it'll be available. I'll now hand it off to Ellen White to start today's presentation. Thank you so much.
Thank you, Davina, and thank you to all of you who are joining us this afternoon. For those of you who don't know me, my name is Ellen White, and I am the Manager of Compliance and Strategy here at RPRA. And as Davina mentioned, we're here to discuss a draft procedure for recycling efficiency rate for hazardous and special products. We are working with Dillon Consulting Limited to develop this draft procedure. And in addition to a procedure for hazardous and special products, they are also developing procedures for us for batteries, electronics, which encompasses ITTAV and lighting. And we did hold sessions earlier in this week and last week on those other procedures. And as Davina mentioned, those sessions were recorded, so you can always go to our website to review those recordings if you're curious about what we discussed for the other programs. So this is a phased consultation, and this is technically phase 2 of the consultation. Phase 1 took place earlier this year between March and April. As part of that phase of the consultation, Dillon and us, we invited registered processors and pros in hazardous and special products to participate in interviews, group sessions, and to provide feedback and questionnaires that would guide Dillon in developing a draft procedure. So what we're going to go through today is the result of those discussions. I will say it's very much a draft. We understand that not everyone could participate in phase 1, and that, you know, the businesses impacted by RER may go beyond just the processors and pros and producers who are responsible. So we want to encourage all of you to provide feedback during the session, taking advantage of that Q&A feature during the session to ask any questions or provide any feedback. And then afterwards, we welcome feedback by email, and we'll provide instructions on how to provide that feedback. So now I'm going to hand it over to Tessa and the team at Dillon to walk us through today's session.
Thank you so much, Ellen. Hello, everyone. Thanks for having me here today. I'm Tessa Blandrum. I'm the Circular Economy Lead for Dillon Consulting. I'm joined here by my colleague, Sydney Baker, who is also going to be presenting today in part 2. So today we will give an overview of the overall timeline for the finalization of the procedure and share with you some of the principles that we used in the development of the procedures. Then we will take you through the procedure in 2 parts. In part 1, we will start by highlighting the major points that we've heard during the interview process, during that phase 1 that Ellen referred to. And we will detail how it was addressed in the procedure. In part 2, we will walk through the procedure itself step by step. So next one. So we started the development earlier this year with background research, reviewing all the submitted verification reports, engaging with our subject matter experts before starting in that phase 1 of the consultation, where we met with processors and pros to better understand current practices and hear what it is we should consider in the procedure development. Then we drafted the procedures, working together with RPRA and with our subject matter experts. And today we're sharing here the results, which is again the draft procedures for HSP. And we very much look forward to receiving your feedback by November 24th. With this timeline, we will be able to finalize the consultation report and the procedure by the end or by early 2024. And please remember that the RER will need to be reported on to RPRA by April 30th, 2024. So to guide, we really want to receive your input on these procedures. You can, as Davina already mentioned, submit your input during the meeting. We will be sending out an email as well with a survey link, which you can complete anonymously or not. You can directly send your input via email to consultations@rpra.ca, which RPRA will forward to us for consideration in the finalization of the procedures. So with that, let's start with the principles. So to guide the development of the procedures, we use a set of principles on which we receive feedback during the interview stage. We used as a principle that the calculation of the RER should be reliable, which means reflective of the actual resource recovery as defined in the regulation and accurate within reason. And that last concept is really important, is something that we have discussed at length during the interviews. And as we apply this principle during the development, we understood reasonability to take into account the impact and the risk of inaccuracy and the processor's potential influence over the accuracy of the data source, and really considering the level of effort that's required to obtain that accurate information. The second principle is that the calculation should be verifiable and auditable. The calculation has to be standardized so that the RER results can be comparable, can be reproducible, and can be fair, which is helping to provide a level playing field for all processors. Next one. For the RER verification, we use the principles of transparency and constructiveness. Transparency includes a reporting of significant positive and negative findings, and the principle of constructiveness really recognizing that the practices of data collection, management, tracking, sharing, they're very much evolving, and identification of areas for improvement should be included as part of this effort. Next one. So as you will be providing feedback on the procedure, we would like to ask you to consider these principles and help us to see how your perception or your concerns or your comments and thoughts, how these align with these principles. Okay. So with that, I'd like to go into this first part where we really reflect on what we've heard during the interviews and how that was taken into consideration. So during the interviews, 4 main themes emerged for the development of the procedures, and they actually emerged across all 3 regulations, though there are some specifics for the 3 regulations. Some of these considerations lay outside of the scope of the procedure review, but they were essential in setting the context within which the procedures will be used and applied. So these include the RER reporting responsibility, the administrative burden and the balance between the burden with the risk and the impact. Really the consideration of what really is a recovered resource, and then the access to downstream performance information. The first key consideration relates to responsibility for RER performance, which lies with the primary processor. It was noted that the RER reflects the performance of the full value chain, which is to a certain extent also influenced by product design and by how materials are collected. Primary processors, however, are solely held responsible for the RER performance, while the influence over this performance spans really the control over their own sales channels, commercial terms, and the design and operation of their own recovery process. Finally, it was raised that the notion of primary processor itself is not defined in the regulation or in the procedure, and that the processors that are required to register and report do not all play the same role in the recycling supply chain. Now, how do we take this into account in the procedure that is in front of us today? Well, the procedure doesn't change anything about the regulation. What the procedure does try to address is any unclarity into whom the procedure applies. And so what we did is introduce an explanation of the activity of processing, differentiating it from the activities that are associated with preparing for processing, and it introduces the notions of primary and downstream processor. So here we say processing is really encompassing activities that alter the characteristics of the materials derived from HSP for the purpose of resource recovery, which includes distillation of solvents and antifreeze, filtration of antifreeze, creating pellets of oil-containing materials, and crushing metal. This would include the removal of non-designated hazardous content from the designated materials. Now, preparing for processing, these are activities that are carried out prior to processing HSP, and they include sorting, cleaning, blending, mixing, and repackaging. And a person who only prepares the materials for processing would not be considered an HSP processor. Now, here an exception, so the removal of non-designated hazardous content from designated materials is considered as processing. Now, the primary processor is the first person or facilities that receive HSP materials used and collected in Ontario and processes these, while the downstream processor receives recoverable resources that were generated from HSP used and collected in Ontario from an HSP processor for the purpose of further processing. So here we introduced a new term, which is a term of recoverable resource, and we'll get to that in a couple of slides. Now, all processing activities are considered within the scope of this definition of downstream processing until the resources can be considered a recovered resource. I know that this is quite important in the context of HSP, so I'm happy to take a pause and see if there's any questions about this particular slide or about what we have discussed so far. Davina, are there any questions?
Nothing yet. We'll give folks a few minutes and see if there's anything before moving on. Okay, we have one question or a couple. So I think this is probably best for Ellen. Are processors outside of Ontario being regulated under the HSP regulation?
Yeah, that's a good question. And we would have to go back to the regulation to make sure that in the specific processor that I'm not giving a blanket statement for all processors outside of Ontario. But what we are saying is that if you are a processor who's processing materials that are supplied into the Ontario market, that you are subject to these regulations. And so that would include that processors who are outside of Ontario. So if they're being sent there, they need to be counted here.
Perfect, thank you. Another question is asking, what percentage of RER is set as the level of reasonableness? Example, impacts less than 5%. Is that the threshold?
Yeah, I can answer that question. We did not define a threshold per se for the level of reasonableness. And you may see from the way that we define this that even, or the way we interpreted that notion, it is open to interpretation. So we very much look forward throughout your review of the procedures to hearing what it is, whether you consider this to be reasonable or not, and why. So the 5% threshold will be discussed later in a different context, which is within the context of the verification and the threshold for material errors in the calculation and the reporting of the RER. So that is not so much about reasonableness, that's very much around whether it's actually correct and in line with the procedure.
Perfect, thank you. This question is asking, which definition might baling, like a container, materials fit? I think you might need a bit more context, or it might need a follow-up depending on your business, but Ellen, could you provide a bit more context?
Yeah, and I'd look to Tessa to provide some insight here too, of whether that one would belong more in the preparing for processing or if that would be actual processing.
I would understand this as being consolidation. So in the case that materials are being collected from multiple locations and then joined together as a larger group, in some cases there may be sorting happening there before it goes to processing, then that is consolidation. It would fall under preparing for processing. If, yeah. I hope that answers the question.
Yeah, and if that person would like to provide a bit more context, please feel free to include it in the Q&A as well. So another question, is non-designated hazardous content the same as non-designated material? And a follow-up to that question, how is the removal of non-designated hazardous content considered as processing? Can you provide an example?
Yes. So is it the same? Well, non-designated hazardous material are non-designated material, but specifically material that is hazardous. So not all non-designated materials are also hazardous. Now, how is the removal of non-designated hazardous content considered as processing? An example here would be the cleaning and preparation of oil filters, where in this case it could be either filtered out or any other type of process where the oil, which is the non-designated product, is separated from the oil filter. However, in this context, it would be considered as processing.
Thank you, Tessa. We have a bit of a categorization question. So are the suppliers of refillable gas cylinders considered processors if they simply collect and refill these cylinders?
Yeah, my understanding is as long as they're being, if you're solely refilling, we are currently considering defining that as not processing. If all you're doing is refilling, but I'd be looking to Tessa as well and share your feedback as well too on where we should land on that determination.
Yeah, correct. So refilling is reuse, is not recycling, is taking out of the consideration of the calculation of any RER.
Thank you. I have another question about timelines here. So Tessa mentioned that the RER will need to be reported to RPRA by April 30th, 2023 or 2024, using a final procedure that will be issued later or earlier in 2024. Ellen, can you provide some context on timelines, just because there are some concerns that producers, pros, and processors will need time to make changes to reflect these requirements?
Absolutely. So as Tessa outlined in the timeline for the development and finalization of the procedure, our expectation is that this would be posted for service providers to start using them in their 2024 reporting. We recognize that this timing is tight, and that in order to meet the standards in this new procedure, that takes time for businesses to implement. So we want to make these procedures available, and we want our service providers to start using them next year in their reporting. But we also recognize that when it comes time to enforcement of these requirements, certainly the tight timelines and the added pressure and work that companies will need to do to reflect them, that will absolutely be considered in our enforcement strategies. So we're making them available. We're asking our registrants to use them in their 2024 reporting. But we also recognize that there are significant challenges to that, and we welcome your feedback on that as well.
Perfect, thank you. Why have you decided to focus on the removal of non-designated hazardous content as processing? Couldn't, for example, bulking of solvents be considered as a form of processing? I believe, Tessa, you might be able to answer that.
We would very much like your feedback on how it is that we have made that distinction and the implications of that distinction. So basically, my question to you would be, if this is something that you think is we should or should not be considering as processing. What we propose here today is that activities that are relatively light, let's say in their actual alteration of the materials considered, that these are taken out of the processing scope. That's why we consider that removing hazardous content is more extensive than non-hazardous content, which is why we kept hazardous content as being still part of that consideration of processing versus non-hazardous content, non-designated content being out of the scope. But again, this is something that we would appreciate to get feedback on.
Perfect, thank you. And then another question on the pressurized cylinders. So refilling is not equal to processing, this person agrees, but if the cylinder is at an end of life, they're doing some processing to prepare it for recycling and recovery. Is that a consideration that you've taken into this procedure as well?
Yeah, so this builds on what I just mentioned. In this case, it would be considered processing if the materials that are removed from those end-of-life cylinders are hazardous. In case there is some preparation ongoing that is about removing non-hazardous materials for further processing, then this is not considered processing. Again, feel free to provide input on that distinction.
Thank you. And we're just looking for some clarification. So on the slide, it says that processing includes crushing metals, which is appropriate for oil filters. However, this person feels like there's a disconnect between the statement and the definition of recovered resources, as the recovered metal would still need to be sent to a furnace for further refining. So could you please clarify if the point of measurement for oil filters will be after the oil is drained and the filters are crushed?
We are in the procedure not literally working with a measurement point, though I understand, I think I understand what this person is referring to. The consideration of whether this is a recovered resource, we'll get to that in a couple of slides, really takes into account whether or not it needs to go for further processing. We have introduced this new notion of a recoverable resource, which is a resource that's being generated through processing, but still needs to undergo further processing. So I think in the case of oil filters, for example, the crushing of the oil filter would be considered processing. However, there's a second step needed that has to do with the refining, which is still processing, but downstream processing. The output of that primary processing step would not be a recovered resource yet, it would be a recoverable resource. We'll get to that in a second.
Perfect. Thank you. That's all the questions for this section. So you can continue with the presentation, Tessa. And for the folks who are online, please continue to send your questions. There will be other places in this presentation to continue answering them. Thank you.
All right. So a second key consideration that was brought forward is that calculating and verifying the RER represent a high cost and human resource burden on processors, and that this burden should be balanced with the risk and the impact of the inaccuracy of the data and the resulting RER. Also, audit and verification scopes sometimes overlap. In the audit development, we have considered two approaches to address this concern. First of all, reducing the RER verification frequency for low-risk processors and reducing the overall effort of the calculation and verification. We have chosen option 2, and that is what you're going to be seeing in the draft procedures. And here is what that would consist of. So, next slide, please. Oh, sorry. Can I see the next slide? Yeah. So this is how we address that. First of all, the verifier may be a first party. The second is that the sampling procedure allows for the verifier to reduce the sample size based on other weight audits that have been undertaken or existing chain of custody models. The third one is that the time frame over which the RER mass balance is to be calculated is reduced from a year to 2 consecutive quarters. And at least the 2 consecutive quarters is what we propose in this procedure. We've chosen that because it seemed that this would allow for some seasonal variations while still reducing in half the total amount of data that is within the scope of the verification. However, we would appreciate feedback on what a reasonable time frame is according to you. Can this be reduced even further, or should it be extended? So another key consideration is really around that understanding of recovered resource, and we got into that a little bit already. The RCEA defines resource recovery as the extraction of useful materials or other resources from things that might otherwise be waste, including through reuse, recycling, reintegration, regeneration, or other activities. Needless to say, this is a very broad definition, and it has the potential to lead to inconsistency in reporting of the RER. Next one. So we considered 2 options to address this. First of all, we considered providing a list of products and commodities, and then already specifying which can be considered recovered or not. We decided not to pursue this approach because this may very much vary depending on the processor supply chain. One processor may send the exact same resource to disposal, the other may find another further refining step, which would ensure that the resource gets recovered. So we consider this approach to be in conflict with the principle of reliability, and therefore we propose to pursue the other option, which is improved guidance on how to determine whether a resource can be considered recovered or not. And how we do this, 3 ways. First of all, we added additional definitions for the purpose of the procedure. I already mentioned this notion of recoverable resource, which is understood as a resource that is derived from HSP that is sent downstream to be further processed. And then there's the notion of a recovered resource, which we understand as a material derived from HSP that will not undergo any further refining and is used as a new product or as a material in the manufacturing of a new product. The second additional guidance is calculation guidance, including guidance on determining the downstream RER, and we'll get to that in a second as well. And the third way is we included some examples of what we would consider to be recoverable and what we consider recovered. Next one. So when we're talking about that additional calculation guidance, that would include flowcharts and formulas to make it more explicit what it is we're targeting. This may seem like a lot, but in many cases, this is already in line with existing practice. It's just ensuring that everybody does the same thing. Now, these formulas that Sydney is going to talk about in more detail later in the presentation, they clarify, for example, that the outgoing weight of materials that are sent for further processing, so the recoverable resources, they need to be multiplied with a downstream RER to get to the total amount of recovered resources through that downstream supply chain. And that leads us to this last challenge, which is how can processors actually obtain this downstream RER? Next one. So what we've heard is that yield or resource recovery performance downstream, that information is considered commercially sensitive. It's not passed on willingly within the supply chain. It's not even always available. The processors may not be given access to this information. They are unable to verify it as well. So we, again, considered multiple options on how to address this. First of all, setting a standard downstream RER for standard commodities. Second would be for processors to obtain an RER statement from downstream processors who then can self-declare their RER in line with the calculation guidance provided in the procedure. And the third one would be to allow the downstream RER to be estimated by the processor based on thermodynamic analysis. Now, in this case, we have 3 options, and none of these options being discussed already during the interview process in most cases. None of these actually received broad support, which is why we also in this consultation today want to go through the pros and cons related to each of them. Just want to clarify that the second option is what is currently included in the draft procedure, but we would appreciate your feedback on all 3. So the first one, this sort of standard downstream RERs. Now, starting with the disadvantages, this does ignore the differences between processor downstream supply chains. So if they do make a choice for enhancing recovery, for sending it to a downstream processor who will be able to recover more of the materials, then that would not be recognized in this methodology. The second is that there are not actually standardized specifications for commodities that are or the products of processing. So if there is no standard categories, how can we have a standard downstream RER? Now, it would be great because it's a very low administrative burden, but we think this is still in conflict with the principle of reliability and therefore have opted for another option. So the next one, the one that is included in the procedure, is that downstream processors can basically self-declare their RER and communicate that to the processor. Now, this also has disadvantages because the downstream processor may not be responsive to processors who are asking for the self-declaration. Because, for example, this processor represents an insignificant amount of their feedstock. Another disadvantage is that it may be really difficult for a downstream processor to determine the RER that is tied to the specific feedstock received, especially if the total feedstock received by this downstream processor is very diverse. There's also not really a strong incentive to really figure this out on in great detail for the downstream processor. Now, the advantage of it is that it aligns with the existing practice in some of the supply chains, and ultimately this has a lower administrative burden for downstream processors because the downstream processors will not need to have this information verified. Next one. The thermodynamic analysis, so in this case, it's basically a theoretical analysis of what the RER downstream can be. Now, this theoretical analysis will result in a higher RER than is achievable operationally, because typically theoretical analysis makes assumption about more or less ideal conditions, and this is hardly ever the case in reality. The other thing is that processors who will be doing that estimation, they may not actually have detailed information on the downstream process. So they may have a general idea about the type of process, but not of the actual installed equipment and how efficient this equipment is, how it's being maintained, and therefore how well it is actually operating. So we know that this is not super accurate. We know this is going to result in an overestimation of the RER. However, this was brought forward as a reasonable approach, especially in cases where the RER may be very difficult to otherwise be determined, such as in cases that the stream of materials received from the processor is very small in proportion to the total diverse feedstock. And ultimately, once you have done this for a first year, the administrative burden may be lower in subsequent years. Now, there may be a lot of questions around this as being a reasonable approach or not. And one of the things that we are looking forward to hearing from you as well is whether there are specific conditions for this to be reasonable, and if yes, what those conditions would be, and what the verification or who would be able to conduct such an analysis, how this analysis should be verified. So we did not further develop this idea in the proposed procedure, but if this is something that you're very enthusiastic about, then we would look forward to getting your feedback on this as well. Now, next slide. Talking about feedback, we do look forward to receiving your feedback on all of these proposed options, hearing from you whether these sufficiently increase clarity on how to determine the weight of recovered resources. We want to know if the proposed options, whether you think they represent the best approach to reflecting this principle of accurate within reason. And then in general, in relation to all the key considerations that we just discussed, we want to know whether in addressing these considerations that we've heard, did we overlook any options? For the options that we proposed in the draft procedure, were any considerations overlooked in terms of how it may be playing out when applied in practice? And we look forward to better understanding if there's any specific challenges that you anticipate with the approaches presented. With this, I'd like to kind of put a bow on this part one and see if there's any questions.
Yes, we have quite a few. I have a definition question for you, Tessa. So the regulation says the weight of recovered resources that may be counted must be from recovered resources that are one, used or destined to be used by a person for the making of new products or packaging, or two, reused by a person. So this attendee doesn't see allowance for destined to be used, excuse me. So shouldn't producers only be required to get material to a point that it is a sellable commodity, and after that they should not be accountable for any changes to the material downstream that may add value? Why is the procedure proposing to impose a bit of a narrower definition of recovered resources?
Well, first of all, thank you for this input. I think this is exactly the kind of feedback we are hoping to receive. I think there are some really good points in this argument, and so I would like to take that away from this session today. And again, this is exactly what we would like to hear, the type of feedback we'd look forward to receiving from you. So thank you.
Thank you. I have another question here about solvents. So currently this attendee understands that solvents going to fuel blend are not deemed to be a resource recovery item, but the household hazardous waste solvents are not commercially recyclable. And this is an industry standard of operation. So how will this be considered for RER for solvents?
It's a really good
Yeah.
really good question. I think, yeah, we're processing that, and that's a really good takeaway for us to consider. Yeah.
Perfect. Keep the takeaways coming. So another question on definition. Will the definition of processing for plastic oil containers be addressed to include plastic flake? Is that something that the team can also take away, perhaps?
Well, I just want to highlight that plastic flake would be more the output of processing and not the definition of processing. If plastic flakes are the outcome, then the question is it a recoverable or a recovered resource? And that would depend on its end destination. So if a plastic flake is going to be going to a manufacturer for the production of a product, then in that case, it would be a recovered resource. So the plastic flake can be considered a recovered resource. I hope that answers the question.
Yeah, feel free to add more context to the person who asked the question. Let's see, the next question, I think for Ellen. So processors outside of Ontario do not have any obligation, and service providers may have no other options for processing. So this attendee is wondering how to manage these obligations. There's competitive quoting for municipal hazardous and special waste that require different costs, and maybe processors that are outside of Ontario and are not registered with RPRA. So how do they resolve this?
Yeah, it's a really good point to raise to us, and it's one that we need to consider, especially in hazardous and special products where there are environmental approval, there are restrictions. It's not like you can send this material anywhere to anyone, and that depending on the material, there may be limited options in Ontario to send that material. So the regulation does require processors of hazardous and special products to register with us. However, our ability to enforce if they're not located in Ontario is different. At the end of the day, though, what we're talking about is the recovery of resources and what producers can count towards their management requirements and what is considered recovered in Ontario. And for us, if you're processing those materials and producers want that material to count, they do have to abide by this RER procedure. But the challenges that poses for businesses who do work with processors outside of Ontario, it's certainly not lost on us, and it is definitely something we're considering as we're developing these procedures.
Thank you. I think this question would be best suited for Sydney or Tessa. But why isn't the sample size to be calculated using the widely accepted statistical formula for calculating a sample size?
Yeah, we'll get into the sampling appendix at the end of this presentation. We have considered a statistical formula. We do look forward to receiving your feedback on whether we should bring it back, as you may have seen that in the draft procedure, the statistical formula is no longer included. However, I just want to relate this as well to the comment that we made on the verifier being allowed to reduce sample size based on certain considerations. I think I want to clarify that what we are targeting here is in case a particular stream has already undergone verification to a certain rigorousness, and that the verifier verifies a particular stream for the purpose of the RER can recognize that this data set has already been verified as part of a different endeavor, or that it has been part of a very thorough chain of custody model or certification scheme, and that they can take that into account and say, in that case, we are going to reduce the sample size. We're not going to reproduce the same effort again, because we have heard from some processors that this is sometimes the case. That's what we're targeting. Again, we look forward to hearing from you whether that's actually what we're going to be achieving.
Thank you, Tessa. This is a follow-up on the solvents sent for fuel blending. So these are typically used in kilns for the manufacturing of cement. So should this now be considered as a form of regeneration or reintegration under the RRCEA definition? I think they mean to say recovered resources definition, but please feel free to correct me if I'm incorrect.
Fuels are not recognized as resource recovery. So that would be the case here as well.
And how will RERs relate to disposal only items such as pesticides?
Well, in this case, as the comment mentions, and we'll get into that as Sydney is going to walk us through the detailed calculation guidance. The disposed items obviously are not considered recovered, and therefore would impact the RER negatively in terms that they're not going to be part of the formula, and therefore they will reduce the calculated RER.
Yeah, maybe I can just add on. So this is pesticides as an example. I know mercury is another one where we've received feedback that the RER rates listed in our regulations may not align with what's currently possible in industry for certain materials, and so we welcome that feedback as well. And we understand that there are certain materials where recovery may not be possible.
I just want to note quickly, I think in the regulation, there's no RER requirement for pesticides. So anyways, double check the regulation, but I do believe that's the case.
Okay, thank you. I think we'll pause the Q&A section right now. Sydney, you can continue, and folks, please feel free to continue adding your questions. There'll be another opportunity to answer your questions towards the end of the presentation. Thanks. Continuing, Sydney.
Great. So now we're going to move on to part 2 of the presentation, which goes through the proposed procedure. So at a high level in the procedure, you're going to see definitions. That's then a section on the calculation of the RER, a section on the verification of the RER, and then 2 appendices that relate to the verification. In terms of the calculation, in this section, there is methods for determining the RER, and there's 2 different approaches that processors can take. We also have general calculation guidance. And then there is the recycling efficiency rate formula, and then how to determine the weight of HSP received for processing, as well as how to determine the weight of recovered resources, which includes the determination of the downstream RER as well. So to get started, there are two approaches considered for processors to determine their RER. It's expected that most processors, or almost all processors, would use the mass balance approach, which is a mass balance calculation based on the total weight of materials received and processed in the specified time frame, which for the HSP is 2 consecutive quarters. The mass balance approach really looks at the total weight of materials in and out of a facility and determines the RER from that. And it will have to be verified by someone meeting the requirements in the procedure, and it would be completed annually. The field test approach determines the RER based on one data set. So it is a field test run of a facility. And this approach could only be used if the mass balancing option is not possible. So for example, that might be for a downstream processor that cannot obtain the information required to attribute process performance to a particular primary processor. The field test has to be done under the supervision of a person meeting the requirement in the procedure, and it must be completed on the interval that's the lowest of once every 3 years, or when there's material changes to the process or to the feedstock. Just some general guidance. The RER needs to be calculated for each facility and type of HSP, and any weights throughout the RER calculation need to be based on calibrated scales. We've also made an allowance that non-designated materials that are identical in composition to designated HSP can be included in the calculation of the RER. And an example here, something that might be identical could be HSP sourced from outside Ontario that are identical in composition. If those non-designated materials are not identical in composition, they cannot be included in the RER calculation and would have to be removed. So here is the formula itself. The RER is calculated based on the weight of recovered resources, R, divided by the total weight, which is going to be the total weight of HSP received for processing, as well as any added materials that might be added during the process that become integrated into the outbound materials, and then multiplied by 100%. So in the mass balancing approach, these weights are determined based on the total weight of materials received during those 2 quarters. And so for oil filters, there's a slightly different requirement there, which is that the RER is based on the weight of the oil filter net the weight of oil. For the field test approach, we have the same formula. The only difference here is that the weights used in this formula will be derived from that one run of the facility. So it's only the weight of materials run through the field test. So going into this piece, we're going to talk about the determination of the total weight. And I'll just note here that this is different between the mass balance approach and the field test approach. So first, I'm going to go through how it's done for the mass balance, and then we'll cover the field test approach later. And really, the determination of the weight of HSP received for processing is done after this preparation for processing phase. So once materials are prepared for processing, that's where you get the total weight. And then that total weight will be sent for processing. So here is a process flow that shows this. So on the left-hand side, you see the opening inventory, which would be any inventory carried over from prior to the 2 consecutive quarters on which the mass balance is being calculated. And then you have the materials received from haulers. So that would be the weight of any materials received during those 2 consecutive quarters. And that makes up the total weight of inbound materials. And then you're going to move into the pink square in the middle there, which is the preparation for processing phase. And during this phase, you're going to remove any materials that are not designated under the regulation, any HSP that's sent for processing at a different facility, and any HSP that's sent for either refurbishing or reuse. And also any weight of materials that are left at the end of the 2 consecutive quarters. So that would be the closing inventory that has not been processed. And once you've removed all of those other materials, that's where you have your total weight of HSP received for processing. And we just want to highlight here, I know this is a small image, so I'm not expecting you to be able to make it out, but we just wanted to highlight that we did create this mass balance template that goes along with the procedure. And throughout the procedure, we refer to steps in the mass balance template that need to be completed to make during that step of the procedure. This is a tool that's made to assist processors in the calculation of RER. Processors can choose whether or not they want to use this tool, but it's there to assist in doing these calculations. Now, for determining the weight of HSP received during the field test approach, it's pretty straightforward. The total weight will be the weight of feedstock used to run the test. However, just to note that it's expected that the feedstock would be taken from materials that have already undergone preparation for processing, so it should only be designated HSP. And also in the verification section, we'll talk a little bit more about the requirements for the feedstock composition. So now that we have the total weight, we're going to move on to determining the weight of recovered resources. And this is the same for both the mass balance and the field test. And this goes back to the definitions of recoverable and recovered resource. So again, recoverable resources are those that are going to be sent downstream for further processing. And recovered resources are going to undergo no further refining and will be used in the manufacture of a new product. So here are some examples of recovered and recoverable resources. This isn't meant to be an exhaustive list. These examples are provided to help a processor understand what the difference between recoverable and recovered is. So these would be some examples that would be considered under the HSP regulation. And this is a point that we're asking for feedback on. I'm not going to pause here, but you can add anything if you'd like. We're going to take some more questions at the end of the presentation, so feel free to add anything in. And I'll just note that in the procedure, there are some additional examples of outbound materials. So that's another list that you could look at to inform your response here. And if there are any additional examples of recovered or recoverable resources that you feel should be added, if you can just identify them as well as what designated materials and processes lead to those materials. So here's a process flow for determining the weight of recovered resources. So on the left-hand side, you see the total weight of HSP received. So that's what we determined in the first step. And it's going to go into that pink box of processing. So also going into the pink box are added materials. And added materials are any materials that are added during the process and are incorporated into the outbound materials. So any materials such as water used to control the temperature of the process that don't become included in the outbound resources do not need to be included in the total weight in the RER calculation. So the outbound from processing is going to be unrecoverable materials, and unrecoverable materials are any that are landfilled, incinerated, or used as a fuel or fuel supplement, or deposited on land. And they could also include process losses such as evaporated water. And then the other two outbound materials there are recovered resources or recoverable resources. And we'll move on to the next slide and we'll go through the formulas of how this comes together. So R is the weight of RP, which is the weight of recovered resources from the processor themselves, as well as the weight of recovered resources from each downstream processor, which is RD1, RD2, and onwards. And when we're determining the weight of recovered resources from a downstream processor, you're going to use the weight of recoverable resources sent to that processor times the RER of that downstream processor. So again, outbound materials are recovered resources, recoverable resources, or unrecoverable materials. And outbound materials need to be summed in groups corresponding to their next processing or disposal destination. So as we saw on the last slide, materials need to be summed by each downstream processor, because when you're determining the weight of recovered resources, you're going to look at the weight of recoverable resources multiplied by the specific downstream RER. So you do have to group them by next destination. And for a material to be considered a recovered or recoverable resource, the processor must be able to demonstrate a basis for that allocation. So that might be a proof of sale to either a manufacturer or to a downstream processor. And for the determination of the downstream RER, the expectation is that the downstream processor will follow the same procedure for the calculation of the RER. So they'll be using either the mass balance or the field test approach. And the downstream processor will provide a letter including a statement which includes the RER, a list of products or materials that are targeted for recovery, and as well as a statement of the average yield per targeted material. And that letter will need to be signed by the site manager or equivalent. And just to note here that where a downstream processor sends materials further downstream, this section should also be followed. So this really feeds into the definition of downstream processor. So I'll just put that up again. And the downstream processor includes all processing activities until the resources can be considered a recovered resource. So really the materials, the determination of the RER does need to go all the way down the stream until there is a recovered resource. And then finally, I just wanted to show this mass balance template again. So this section here shows the determination of R as well as the calculation of the recycling efficiency rate. And I just wanted to flag as well that the mass balance template can be used as a resource for processors to ensure that all their data lines up, because it is a mass balance calculation. Although it's not shown on the page here, there is a section of the mass balance template that allows a processor, if the mass balance has been done correctly, it will sum to 0. So there will be a sort of a verification step within the template as well. And now moving on to the verification, I'm going to hand it back to Tessa.
Thank you so much, Sydney. So the verification portion, oh, sorry, I'll put my video back on. Apologies. For the verification piece of the procedure, that consists of 3 parts. One is general guidance that applies to the verification of both the mass balance calculation or the field test approach for determining the RER. And then there are separate sections for the verification of either one of the 2 methods. So next one. As part of the general verification guidance, the credentials of the verifier are specified. And these requirements are the same for the verification of an RER calculated through the mass balancing method or through the field test method. So a verifier needs to be a licensed professional engineer in Ontario or equivalent in any other Canadian province. And if the facility reporting is abroad, the verifier needs to at least have a master's in engineering or in science in a relevant engineering discipline with 3 years of demonstrated experience in an operational setting, or have a bachelor's in a relevant engineering discipline with 5 years of demonstrated relevant experience, or should have a verification certification from an accredited body relating to national or international environmental standards. Now, there's another requirement, and that is that the verifier must have physically toured the facility. They should really be familiar with the process that they're verifying. And this means that they have to have the ability to assess the processes that are being considered by the RER, assess the modeling approaches, the assumptions, as well as the sort of magnitude of potential errors or omissions and misrepresentations. And they should be able to do so to be able to assess the information systems for gathering and reporting data, including any quality control systems or procedures. Now, the second portion of the general guidance is relating to material errors. A verifier needs to report on material errors that they identify in the RER calculation. And what this specifies really is what should be considered material or not. This has a qualitative and a quantitative part to it. From a quantitative perspective, an error in the calculation or in any input into the calculation is considered to be material if its value exceeds 5% of the total weight processed. A qualitative material error, that would really refers to more intangible issues that may affect the RER statement, such as control issues that erode the verifier's confidence in the reported data, or difficulty in locating requested information, or any non-compliance with regulation that are indirectly related to the RER. Next one. So for the mass balance method, throughout the full verification process, the verifier will be required to conduct the following activities. So, of course, assessing the actual data based on completeness, consistency, and accuracy, assessing the methodologies that are chosen, checking that the assumptions, the references, and the data sources are clearly disclosed and reasonable, and identifying any challenges that require further analysis. Now, the verification procedure here would consist of 3 steps. One being the actual data and calculation verification, then a step where the verifier assesses and evaluates the RER, the resulting RER, and then the verification reporting. Next one. So to give an idea of what this consists of in the procedure, so for step A especially, this is quite a detailed part consisting of 8 steps, which really relates to the verification of all inbound materials, outbound materials, the materials that have to be excluded from the calculation, the weight of unprocessed HSP, the weight of the recoverable materials, and that determination of the downstream RER. This then has to result in a full mass balance to be verified, and the resulting RER has to be recalculated. Now, these come with sub-steps as well. So here's an example for step 2, which is the weight of the materials to exclude from the inbound weight. The verification would, for example, consist of the assessment of the input in cases, for example, a composition study or a tracking system has been used to assess that methodology. There is an appendix that further describes what the verifier should take into account when assessing methodologies. But if these inputs are being measured, then it would consist of verifying, for example, a calibration log of the scale. Now, for another example, for the outbound materials, verification would really consist of comparing the data points with the actual bills of ladings or manifests, focusing on the confirmation of the weight, the confirmation of the categorization in the data set. So has it been categorized accurately as recoverable or unrecoverable? In the case of hazardous waste, this categorization should align with the mentioned disposal code as well. And it should look at the actual destination. Next one. So after having completed this, the verifier evaluates the RER statement, taking into account the sufficiency and appropriateness of the evidence, any material misstatements, the conformity with the calculation guidance and requirements, and any changes compared to prior reporting periods. And then step C, this is the reporting, 9 parts. This is largely similar to what we have discussed during the interview stage. This report, we have proposed to limit that in length to make sure that when verifiers are consistent, not turning this into a huge report. So 5,000 words in this case is proposed to report on all the findings. So now on to the field test. The determination of the RER using the field test method requires 2 documents that have to be signed off by a field test verifier. One is the field test plan, and the other one is the verification report. The field test plan consists of the following. So a specification of the feedstock composition, which should be chosen such that it is representative of an average sample of obligated materials that are collected from consumers in a year, and should specify also the methodology for deriving that feedstock composition. It should specify the operational settings. Again, these have to be representative of normal operating conditions. It should specify the batch size and the test duration that allows for these results to be representative of normal operating conditions, and it should specify a data collection approach. It has to be signed off on by the verifier and the facility manager. The verification report, so the report that will be sent to RPRA, would include an explanation as to why the processor is using this approach and why they cannot use the mass balancing approach. It describes the verifier competencies, the field test process, including a statement of how the feedstock and products targeted in the design of the test, how these were determined and how these are representative of normal operating conditions. It should include a summary of the RER calculation inputs, now outputs generated through the field test, a list of outbound materials from the processing facility, and the corresponding destinations. And then when we're talking about corresponding destinations, these are not just the destinations from the field test, but these include the destination from all the locations where the processor sent materials within the last 12 months. It includes the field test plan as an appendix. It includes, as is the case with the mass balancing method, a verification statement and review declaration. So I promised to say a little bit more about sampling methodology and Appendix B on the methodology verification guidance. For the sampling methodology here, it is stated that the samples should be equivalent to at least 50% of the total weight of inbound or outbound from that facility. They should be taken across inbound source types and outbound destinations and material types. And again, more than 50% by weight should be verified. The reason why we stepped away from a full statistical analysis is that within those categories, sometimes the sample size is not big enough for a statistical analysis. So if you already break it down per specific type and location, in some cases that becomes not as representative. Again, if this is something that you would like to see back or you would like to see applied, if there is a certain amount of a certain population size to be considered, that is something that we're definitely, would like to hear from you. Again, this, and as I explained earlier, this is a recommended sample size, and we propose for this to be allowed to be reduced at the discretion of the verifier, considering, for example, any other weight audits that have been undertaken by other competent third parties that are demonstrated through either audit reports or certifications. It can be chain of custodies, it can be, and it has to take into account that the scope of such audits or proof points really overlap with the relevant parts of the verification execution scope, so that the risk adjustment really only applies to what has already undergone auditing previously. So Appendix B, this is the guidance for the verifier, what they should keep in mind when reviewing methodologies. We propose the following factors: that the methodology is appropriate for the process being considered and based on an understanding of the material flow of the facility, that the methodology should be reflective of the feedstock average composition and variation and of total quantities received and processed. It should take into account or look at whether the inputs into the methodology, whether these were generated within the time frame for which the RER is being calculated, and that the methodology has been updated to reflect relevant process changes if there have been any. So with that, I handed it back over to Davina.
Yeah, we can go to the next slide first. We'll do some questions before we get into our consultation feedback. So the first question I have here, probably for Sydney. So is packaging or containers deemed as part of total weight, and therefore those packaging or containers going to disposal would be a negative value, and a recycling would be a positive value in the calculation? Could you clarify?
So if the packaging and containers are designated HSP, then they would be included in the total weight. On the second piece, yeah, if any of those packaging and containers go to disposal, then it would not be a recovered resource. So yes, and anything that is recycled or becomes a recovered resource. So in the calculation on top, you're going to have your recovered resources divided by your total weight and added materials. So yeah, any total weight that is not turned into a recovered resource will lower your RER efficiency rate. So I hope I've answered the question there.
Thanks, Sydney. I have a question for Ellen. So for some materials, the point of measurement has changed substantially from the point of measurement in use when the ministry set the RERs in the regulation. So this attendee is wondering, is any real world testing taken place? And if not, will it take place with the results being shared before the procedures are finalized?
Yeah, so absolutely in developing this procedure, we've tasked Dillon to consult with subject matter experts and try to get that real world experience and that understanding as part of the development of these procedures. If you have specific feedback about testing that you feel is crucial to the development of this procedure, please feel free to share that feedback with us. We're welcome to entertain that.
Thanks, Ellen. And I just have a follow-up to that question as well. So is the ministry willing to make adjustments to the RER in the regulation to reflect these changes to the best of your knowledge?
Yeah, and there's I know the related question there around mercury as well. So, and we often say this as RPRA, it's our mandate to enforce regulations that are set by the ministry, and any decisions around regulatory amendments, they do come from the ministry. So I would encourage you to contact them directly with this feedback. Certainly it's part of this consultation. It'll be reflected in our consultation report, and so it'll be public information. but specific requests or recommendations for amending the regulations should go directly to the ministry.
Thanks, Ellen. One more question for you exactly on mercury. So mercury doesn't meet the definition of recovered resource because there's no market for mercury in new products. So shouldn't this category C, for example, thermostats be exempt from the RER calculation?
Yeah, that's again a fair point, and it's one that we've heard before. We do have to ensure that our procedure aligns with the requirements within the regulation. But of course, we have heard this concern, and we would encourage you to contact the ministry to share this feedback. But again, it's part of our consultation and will be part of our public consultation report.
Thank you. And I have a question on verifiers. So is there any consideration to allowing verifier credentials to be at a managerial level? So some consideration to smaller companies with experience in this sector that are already familiar with verifying data, or do they have to have the set credentials that are outlined in the procedure?
Yeah, I can respond to this one as well. This is really good feedback for us to have. Of course, the reasonableness of our procedures and how they can be applied by small businesses is definitely a concern for us. So this is feedback that we'll take into consideration.
Thank you. And then some questions on transfer stations. So how are transfer stations as consolidation points and in some cases pre-processing like sorting regarded in these determinations?
Yeah, I can answer that. So as per the proposed definitions, this would be considered preparing for processing, and therefore is not considered within the scope of the RER. If this is part of one process, it should be deducted. If it's an entirely different stage, such as would be the case with a transfer station, then that would just not be considered within the scope of the RER at all.
Thank you. And then questions about the RER calculation and verification procedures. So has the cost of completing the RER calculation and verification using the draft procedure for typical existing HSP processing methods been estimated in the development of the procedure? And have they been implemented in any way and not just consulted on?
So I can speak to this as well. Certainly, we are very, very interested in hearing feedback on any impacts to costs for your businesses on implementing the draft procedure as written. We do need to make sure that these procedures, while aligning with all the principles that Tessa described, that they're achievable for businesses that are subject to them. And so we would welcome that feedback. Tessa, I don't know if you have anything to add on to that one.
No.
Hey, thank you. So how is the recoverable or recovered materials weight for the field test RER? How will it be verified? And what RER for the downstreams, what are they assumed to be?
Yeah, I can answer that. So the intent is for the field test to take into account, as I mentioned, a certain composition that's representative over the year that will result in a certain amount of recoverable and recovered materials. These don't by themselves need to be verified in the sense that the test plan is being verified itself. In the development of the test plan and in the data collection method description, this will result once the test is executed in a certain amount of recoverable and recovered materials. These need to be multiplied with the downstream RERs. So the scope for collecting the downstream RERs would be the same as for the mass balancing method. And these downstream RERs have to be proportionate to where the loads were sent on average in the last year. So I hope that clarifies it. Maybe this is also a good point to take into consideration. Maybe this is something we need to clarify in the procedure. So thank you for that comment.
Thanks, Tessa. I'm just going to be launching a poll quickly just to get some feedback on our consultation so we can improve our webinars. If you have more questions, please continue to add them to the Q&A tab. We have a couple more to go through, but I'll just leave this poll up for about 60 seconds. If we could please get your feedback on how we can improve our consultations, we'd really appreciate it. Perfect. Thank you so much. So we have one more question in the queue here. So similar to the oil from oil filters, is the weight of gas from pressurized gas cylinders to be removed from the RER calculation? Tessa or Sydney, maybe that question is for you.
In the case, I think that this should be removed because the gas itself is, to my knowledge, is non-designated. It's the cylinder itself. However, I would doubt whether this weight is significant. So I hope that addresses the question. I know that there may be some challenges in determining that weight. So maybe if you have any suggestions as to how this should be clarified in the procedure, we are happy to hear that.
Perfect. I'm not seeing any more questions in the queue. So I'll hand it over to you, Tessa, to do our closing remarks.
Yeah, I would like to thank everybody for your time today. I would like to thank you in advance for all the input in really helping us understand what implementation of these procedures would mean for you and what your thoughts are about what we have proposed today. So again, we look forward to receiving your input and thank you so much. Have a great day.
Thank you, everyone. Take care. Bye.